All right, let's get started. Okay, so we get the point, right? When you want to visualize the distribution of a numeric variable, and if that variable is very unevenly distributed, right, like this one, right? So if you directly observe that appearance variable, you will see something like this. Now, what you can see in this figure is like most of the people are like almost all of the people are within 0 and 500 appearance, right? That's what you can see in this figure, and there's no information, isn't it? Right? You just see that most of the people is like within 0 and 500, right? But if you apply a log transformation, this is what you see, right? You can see that this many people appear only 1 time, 2 times, 3 times, and this is 4 to 7, right? And this is like 8 to 10. Sorry, this is 3, 4, 5, and this is like 7 to 10, right? Isn't it? And as you can see that when we go to, for example, in this one, log 2 is actually 100, right? So the height of this bar, about 300 people, they are actually within 64 times and 100 times. See that? So with this log transformation, actually the coverage of each bar is getting wider and wider, right? So in this way, it's easier to observe the distribution, isn't it? Okay? In compared to this one, okay? Do it this way, it's easier to observe. The number actually do not change, okay? But we use a different angle to observe the data. We can say that, right? So you apply log transfer to give you a better angle, to give you a better filter, right? So you can observe the data better, right? That's the point of log transformation, okay? Now let's get to the next thing. So far we are examining the numerics, right? But they are variable which are categorical, isn't it? Right? For example, like a line. A line, this variable, is actually has 3 different values. Okay, it has good, bad, and neutral, right? So but so in nature it should be a factor, right? Okay, so and sometimes we also want to do some we also want to examine this variable, right? When we are examining factor, we actually want to know, right, how many occurrence of each of the values has occurred in this factor, isn't it? Right? Actually, this is also some kind of like histogram, some kind of like distribution, isn't it? Right? Here, when we say distribution, we are talking about the distribution of numeric number, right? But here, this variable is not numerics. They are categorical, right? So if you want to see the distribution of a categorical variable, we are actually counting, right? Counting the occurrence of each of the categories, right? So the function to do this counting is called table, okay? So it's easy, right? You just put the vector here. And this vector, it could be a character vector, it could be a factor vector. It does not matter. As I told you, right? In R, well, they can use kind of like interchangeably. Okay, so you put a character or you put a factor here. Actually, you can also put a numeric here. If you put a numeric here, you will count like each unique value, right? 1, 2, 3, 4, 5, kind of like that. Okay. So you use table, you can actually list and count the numbers of category or discrete value, right? In this factor, right? So usually we will kind of like this is the distribution, right? So the next thing is we want to visualize the distribution, right? So to visualize the distribution, we actually can pipe the table into a bar plot, okay? And again, this argument is just to give the figure title, okay? So in our environment, it's very easy to examine categorical variable, okay? You can do it like sorry. Where is my D align by itself is a vector, right? Right? So character vector. So if we put it into a table, you will see, right? It counts each of the unique values, right? So if you want to visualize this distribution, we kind of pipe it into a bar plot, okay? That's all you need to do. And you see it already, right? Okay? So in our environment, it's very easy to like kind of like examine the categorical factors, right? And in categorical factor, we also would like to know their distribution, right? Okay. By distribution, we mean that how many times each of the unique value occurs, right? The frequency of each of the unique value. Okay. The only difference is like when you are looking at numerics, because the numerics are continuous, can be represented in the continuous line, right? But the categorical cannot, right? Each one of these characters, they are like discrete value, right? They do not have an order. They do not have a. They are not continuous, okay? So every bar represents a unique value. It's unlike in the numeric, every bar represents the interval, right? That's the difference, okay? Now let's get back to our notebook. So I think up to this point we already kind of like review some of the statistical terminology that would be very useful in our subsequent discussion, right? What is distribution? Why do we need it, right? Well, one of your homework assignment is try to answer this quiz, right? Okay, like in the last time, right? So one of your personal homework assignment this week is to finish this this notebook, right? By answering these questions, okay? So I'll leave it to you, okay? Now let's go into section 3. We are talking about character vector and factor, right? Just we mentioned this earlier, right? So, and I told you that in R they usually can be used interchangeably, right? But there are some situation, there are some condition that in some situation you would like to transfer a character into a factor and make things easier, right? Basically, there are two major reasons you want to do that, right? One of the reasons is you want to impose a order on the labels. For example, like good, neutral, and bad, okay? If you do not specify the order, the label will be ordered in alphabetical order, right? As you can see here, it's B, G, and N, right? Well, sometimes it is desirable to put N between good and bad, right? Well, sometimes for like visualization or for some reason, you want to have good, neutral, and bad, right? It's more, more meaningful, isn't it? Okay. If you want to do that, then you can actually convert the character into a factor, okay? The way to do that is to use this factor function, okay? So in this factor function, you give it a character vector, and you specify the labels, okay? And when you specify the label, you can specify the order, okay? So this is function call, and this function call actually convert the align from a character vector into a factor vector, okay? And the outcome is assigned to df dot align. Actually, I want to create a new column, right? Called f dot align, right? And this f dot align is actually factored instead of a character, right? So let's see. Let's go back to RStudio. So before I execute this code chunk, you can see that we have a column called align, and it's of type is of character, right? So as I say that if I apply this function, I can convert this column into a factor, right? And I want to put that new, I would like to create a new column here, okay? I want to create a new column here that represent this vector, okay? So after I execute this code chunk, you will see that there will be a new column appear, right? See, okay? Don't worry about this. Usually this is because we okay. It happens when you have do not have enough of space to do the plot, right? So I mean, this type of warning, you can like just ignore them, okay? So as you can see that here we have a new column, right? And this new column is a factor column. See that? And this factor has 3 labels, right? And the 3 labels would be in this order, okay? So now if I do a see, here I do a two thing, right? In this figure, so actually I do a table on the character, and I think we can see better here. So if I directly apply table to this character vector and do bar plot, I will see that bad, good, neutral, right? But after if I do it on this f dot align, because in f dot align I already specify the order of the labels, right? So it would be the bar plot would appear in the order as our wish, right? So this is one reason that you want to like convert a character into a vector, right? It's one reason, right? Let's do one more exercise. For example, if I if I convert I into a factor and put it back to the I column, right? In this way, I do not create a new column, right? If I do this, I actually convert the column of I from character into factor, right? We can see it here. Now we can see that I is of type character, right? So after I execute this point, because I assign this back to the same name, right? So it would like update the name. So after I execute this, you will see that here it would become a factor. Okay. See that? Okay.
Professor, the bar plot above, I am unable to run it on my laptop. It says that it's an error, and it's the same code as yours. I haven't changed it.
Can you do it this way? Can you press this button first? I mean, you press this button and it will execute all of the. It will execute the notebook from top. Okay. Now you can do it, right? Okay. Yeah. Because if you sometimes like jump into the middle and some of the thing you are not defined, right? Okay. So you can, if you run into trouble, one way to get out of trouble is press this. Then you will like execute all of the things on top of it, and then you execute this block. Usually you will solve the problem. Okay, so we are here, and we change I into a factor, right? Okay. Now notice that when I call this factor function, I do not give it the label, right? So by default, it would just like use alphabetic order to right. So when I do, you can see that the labels inside I is actually in alphabetic order, right? If I do not specify order of labels, it will like just use the default alphabetic order. Okay. Now, if I do a table on I, again I can see that. What does this mean? It means that we have like 619 character has black eye, right? We have like 207 people has yellow eye, right? That's what that means. And of course we can like, if you want to visualize with a bar plot, okay? It's very easy, right? Okay. But here, between the table and the bar plot, I put a sort, okay? A sort, I mean I want to like sort, I want to order them from descending, in a descending order. I want to rearrange the vector in the order of descending way, right? So in this way, I can see that if I run this, so I can see that most of the people has blue eye, right? And yellow is the rarest number of eye, the rarest color of eyes in this data set, right? Okay. So if you do not use sort, as you can see that it's in alphabetic order, right? So if I want to order them numerically, I can put a sort, okay? And when I use sort, it actually default to ascending order. See, if I do not put anything within sort, okay, then by default it's ascending, okay. And if you want to specify descending, you can say equals to true. Okay. As I told you, that if you do not know, if you want to know the argument of a function, you can place a cursor on the function name and then press F1. As you can see that sort has a like decreasing kind of. So if you put this decreasing to true, then it will be in the decreasing order, right? Okay. So and then Barbara. Now, as you can see that the function call in R is like basic movement, basic operation, and when you chain this basic operation together, it's getting more and more powerful, right? Okay. Now, now we have this data frame, and in this data frame we have a new factor. We have a new factor column, and we also convert original character vector into factor, right? Okay, let's do summary again. Can you see the difference? As you can see that for all of this character, columns, when you do summary, it basically cannot give you any information, right? Because they are character. What information can you get, right? But if it is a factor, you actually list the you actually list the kind of like do a table, right? You list the most occurrence labels here, okay? And for I, because I color has I mean there are like 10 type of I color, I guess. I do, sorry. So you can see that it will list some of this, right? The label here, right? For factor, when you do summary, you actually count the number of occurrence of each unique value. But for this one, right? Okay. See, for a line, it is a character. So when you do summary, you see basically nothing, right? But F align is actually a factor, right? So when you do summary, you actually count the number of each label. Okay? That is the second reason that you want to convert character into a factor. Okay? When you do summary, it is summarized better. Okay? So other than these two reasons, in most of the case, you just use factor and character interchangeably. And sometimes, especially when you are doing a lot of character stream operations, right? Use character is actually easier than using factor, right? So right now, I don't recommend you to like transfer every factor into a factor. Maybe keep it as a character type is good enough, right? Okay, so this is the factoring versus characters. Any question? Okay, no question. Let's go. Let's move on. Now let's do some ordering and filtering. Okay. Previously, you already see this function sort, right? Okay. So for example, if we want to pick out the if you want to list the top 10 character by their appearance, right? I want to know the 10 character that appear most, right? That has the largest number of appearance. I want to do that. From time to time, we want to do this, right? Okay. So what can we do? If we have the sort command, right? So we can this is appearance, right? Okay. And we sort appearance by descending order, okay? And then we use head to get the top 10, right? So if I do this, what would I have? I would actually have a vector of 10 integers, right? Okay? Because you sort the things in descending order and extracted the first 10 elements, right? So the results is actually appearance, right? So you see these 10 integers, but who they are you cannot see, right? that's the problem, okay? So so the sort is good, but it actually returns the sorted content of X, right? X is a vector, right? You sort X, it actually returns the sorted content of X, right? So because appearance is integer, right? So after sort, it's still that integer, right? But now you not only you not only want to know the number of appearance, you want to know the name, right? Okay. So in order to do that, you cannot just do sort, because if you just do sort, you actually will see something like this, right? The information is incomplete, right? So a better way is to do this. Thing. It looks a little bit complicated, but we already learned all of these things. We are just using indexing, right? Okay. So the order, a new function that I want to introduce here is called order. Okay. The order is different from sort. Instead of creating the sorted content, it actually produces an index. Okay, it produces an index so that the let me do it in this example. It will be a lot easier. Okay.
But Professor, in this case, when you index it, does it change the main data frame, or only?
No, when you do this order, let's see here. Okay, I'll explain this, right now. Okay, so as you can see, that what I'm doing here is actually I'm doing indexing, right?
Mm-hmm.
This is the original data frame,
Yeah.
right? And then I use this angle basket, which means I want to index into this this original data frame, right? Now, a data frame, you need two index, right? This is the column index, and this is the row index, isn't it? Okay, so the column index is easy. I just pick out the information I want, right? I want the name, I want the appearance, I want the year, okay? So I just specify the column that of my interest, isn't it? That's for column. Now for the row, I'm using this order function to create the row index, okay? By decreasing appearance. See that? So this expression, it means I want to create an index by descending appearance. Okay? So if I put this as the row index, and I put this as the column index, okay? The thing is, this expression is the same is not the same as the original data frame, right? The original data frame is still there, right? But this expression, it actually pick up 3 columns, right? And also it order the row by descending order of appearance. Again?
So the data frame remains as is.
Yes.
With this command, we just remove, like, copy data and put it in our.
Right. Let's go into RStudio. Let me demonstrate to you. Okay. See, we are here, right? See, after I execute this one, the original data will not be touched. Okay? This is the expression, right? And when I execute this expression, it's actually just the index operation. Let's see what happened. Okay? See? Okay? The D is remain the same, right? It did not change. Okay? But this expression would be evaluated, would be computed, and it would produce a data frame like this. Okay? The data frame is like, as you can see that it's still 7250 row, and also but it only has 3 columns, right? As you can see that. If I want to save it into a new data frame, okay? For example, for some reason, if I want to save it as a data frame, if I do this, I will have a new data frame. Okay? Okay? If I do this, I will have a new data frame called DF, right? And this DF data frame, as you can see, it has like this many row and this many column. Okay? But so far, I don't need this new data frame, right? I just want to see the top 10 row of this data frame, right? So I just want to see the first 10 row, right, of this data frame. So I can do this, right? And when I execute it, see, I can see the character that appear most, right? The top 10 character who appear most in this data set. Okay? You get the point? Okay. So order, unlike sort, it would not sort the original content. Instead of sorting the original content, it actually produces an ordering index. Okay? So that you can reorder a data frame as you wish. And in this case, we kind of like reorder this D data frame by decreasing appearance. Okay? In order to extract the 10 most appearance character within this data set. Okay. Okay, so let's do more exercise. Okay. So now there's another the operation that I just demoed to you can be do in several different ways, right? Another way to do that is do a subset. Okay. The subset function actually pick out the row and column by condition and by name. Okay. So for example, if I want to see the I want to see the deceased female. Okay. If I want to pick up the deceased female, right, and I want to pick up 3 columns, okay? You can do this by indexing, okay? You can also do it by subset, okay? If you want to do it by subset, then you can do it this way, subset D, and then you put in the condition, right? The condition, if you have multiple conditions, you can like concatenate the condition, join the condition by using ampersand, okay? So you put a condition here as the second argument, okay? And you put the selection of column by their name, right? So after I execute this, I will have a D data frame, okay? And then if I want to like, if I want to, in this D data frame, if I would like to pick up the 10 most appearing character, I will do this order again, right? And this time it's not the entire population, right? And this time I'm doing this ordering with condition, right? Let's do the exercise here. Let me remove the df. Okay. So now before I execute this command, I only have a capital D data frame, right? And when I do this, see, I will create the data frame. It's only like 532, right? Why? Why the number of row is decreasing? Because I'm applying a condition, right? In this lowercase d data frame, I have 3 columns, right? Because I only select 3 columns, right, out of D. And I only select 532 observation because I'm applying this condition to D, right? And as you can see that if I do not set this expression into a variable name, you simply just print out the result, as you can see. Okay. So but I don't want to do that. I want to save it into lowercase d, right? So save it into a D, and then I can do an ordering to pick up the top 10 most appearance deceased female, right? So this is actually the most appearance deceased female in the entire data set, right? Okay.
But in this case, we made a data frame, a new data frame.
Right.
What if, so before this, when we were just ordering it, we made a table. Can we do the same in this case? Not make a data frame, but make a table with the exact same values?
You mean you don't want to have this intermediate
Yes.
data frame
No data frame.
and directly do this?
Yes.
Well, it would be kind of difficult, okay? I can do that, but the syntax is would be a little bit too complicated for you guys, right? So don't. Now this is a good ambition, right? Yeah, try to do everything in one shot, right? But for beginner, I would suggest that you might want to like divide and conquer, right? When you put too much complexity in a single line, most likely you will have an error, and most likely you will not see what the error is, what it means for you, right? So it'll be kind of like frustrated, okay? And when things come to this complexity and you want to switch everything into one line of code, even for a sophisticated programmer, I don't recommend them to do so, okay? So there are ways to do that, but you will need to do a very complicated expression, and that I don't want to. I want you to do that. So you can use the data frame, and then you do that. Now now let's do some exercise, okay? Let's do a group exercise, okay? So we have team 1, right, here, and team 2, team 3, and for rest of the people who still do not have a team, I recommend you like stay together, right? So we can do some team competition, okay? Then we'll have some good prize for the team, okay? Now, list the top 10 appearing female character of brown hair and green eye. Okay? And when you finish, like, raise your hand. Now, the best way is, I mean, you can, like, kind of, like, reuse the existing code, right? Like, use the existing code to do modification. It would be a lot easier than trying to do it from scratch, okay? Modify the existing code to try to accomplish this thing. When you finish, like, raise your hand. Any team get the answer? I mean, you can just use this, reuse the code, right? Reuse the code, it will be easier. You got it, right? You should have a list of like 10 uh
Variables?
no, you should have a list of 10
Observation.
characters, right? 10 female uh, 10 female, brown hair, green eye female, right? Blonde hair, green eye female. And you want to have the top 10 most appearance. This is conditioning plus filtering, right? Finish it? I mean, you don't want to do it from scratch, right? You can like reuse the code and do modification. It will be a lot easier, right? Okay.
For me, I don't need 10 people. I need 3 people, and then the other 7 are like NA. So non-appearing.
NA
They are non-appearing.
should not be the case. Okay, it should not be the case. Well, actually, we are a little running out of time, so let's try to do it together, okay? Let's try to do it together. Actually, I already give you the answer in your in your notebook. Okay, so see, we are talking about brown hair, green eye female, right? Okay, so first thing is to do the condition, right? So the condition should be brown hair, green eye, and female, isn't it? Right? And then what do you want to select? You select year, appearance, name, right? Actually, you can select more. For example, in this case, you might also want to select the sex, eye, and hair, right? Okay? Now, if you do it this way, you should have a. If you do it this way, the lowercase d data frame will be, right? It will become 55 rows and 6 columns, right? Because I'm selecting like 1, 2, 3, 4, 5, 6 columns, right? And I'm specify this condition, right? So if you look into this smaller d, you can see that all of the character in this data frame, they are all the same, right? Female, green eye, brown hair.
I think I got it.
You got it, right? Okay, good. So you got the same thing, right? Basically the same thing. In the lower capital D, you should have 55 column, and maybe you may not have these 3 columns, right?
I got a table, but it doesn't look the same.
Doesn't look the same? No, not finished yet. This is not finished yet. Okay, this is just the first step, right? So we do the condition, and then we want to order the outcome, right? In this way. When we order the outcome in this way, we'll see. Now this is the top 10 appearance. Green eye, brown hair, female. Right? You get the point? You get the point? So can you get the same answer by yourself? Try to do that, right? Divide and conquer, right? See, we want to, in this operation, you need to do some column indexing, some row indexing, column indexing, and also you want to do some ordering, right? Do some ordering. So you just put together a few things and divide and conquer. You can accomplish the tasks. Okay? Everyone get it? Okay? You get it, right? Anyone need more time? Now let's do another one. Let's do another one. This time I want to be careful. I want to use the 5 least appearing red hair, red eye male. Okay. The least appearing red hair, red eye male. Okay. And I want this information. Okay. Actually, the answer is there in your notebook. Okay. But I want you to try to like do the exercise by yourself. Okay? It's 11 o'clock, so let's take a 10 minutes break, and you can try to like maybe discuss within your group, right? Okay. This is important because later on we will have some group competition, and this is the basic operation that you want to learn, right? Well, this is the most basic thing that we want to learn when we're doing data processing. But as you get familiar with it, you will use it like every day, okay? So you will be familiar with them very soon. Okay, okay, let's take a break, and then we will resume the class at 10 after 11. Yeah. Okay. Okay. Yes. Okay. Okay. Oh, wait.